I would like now to move to Mr. Ramon Garcia from Global Factor, who will give us an introduction to the FLAMINGo project. Yeah. Hello, Ramon.
Hello. I will share my screen in a moment. Well, are you seeing my screen? I guess. Yeah. Well, hello everyone. I'm Ramon Garcia from the Net Zero and Carbon Footprint Department in Global Factor, one of the FLAMINGo partners, and I'm here to talk about the life cycle analysis approach in FLAMINGo. And I would like to do a quick introduction of this project, and then my colleagues Jose and Jimena will go deeper into net zero and circular economy topics. So here we have the contents that we will see in this presentation, overview of the whole project, talking about the concept and objective, partners, work plan, approaches, and methodology. And we will talk about the industrial need of initiatives like FLAMINGo, and then about this LCA and LCCA approach. Then we will finalize with the conclusion from now. Well, the overview. So this FLAMINGo is an acronym for, FLAMINGo is acronym of fabrication of lightweight aluminum metal matrix composite and validation in green vehicles. The objective of the project is to develop an electric vehicle made of lighter materials while reducing its environmental impact and the economic impact too, because we are now doing the life cycle and life cycle cost analysis. We have partners around all Europe. You can see here in the map, and the life cycle analysis approach is to make a reference for the manufacturing process of the electric vehicle, then obtain all the data for the improvement of this this process with all the FLAMINGo knowledge, and then compare to the reference with the improvement of this environmental and economic impact. So we can prove that this enhancement of the process helps to reduce these impacts. So we can see now a simplified overview of the whole process in the project. First, we have the primary and secondary aluminum manufacture, where nanoparticles of aluminum and master batches are included in the material. Then we have the foundry process and the designed. These pieces are designed with topology of optimization. This process helps to reduce the amount of material used in each piece, and this reduce of material it's directly impacts in the environmental impact. To less material, we have less environmental impact because the use of material is reducing in the process. So we have extrusion or die casting techniques for making the chassis, the body of the electric vehicle, and then the final stage of the life cycle, that is the recycling of the components of the vehicle. This may be a key process or key stage, because the environmental and economic impact in the next generation of vehicles, it may the recycling will impact this in this environmental and economic cost. Okay. Yeah, the main objective is to validate and demonstrate the cost-effective processing solution for the automotive industry, not only for the vehicle, electric vehicle, instead of all the process, all the industry, as well as following the principles of circular economy and cradle-to-cradle approach. As we said before, these improvements have positive consequences in the economic and environmental performance of the process. We have like three stages of objective related with the development of technologies, demonstration activities, and market replication. And every partner, depending on their expertise, can afford every one of the objectives. The main specific challenge in this case is related to the improvement efficiency and range of electric vehicle through the production and use to recovery. We can see here the SWOT analysis, and related with the LCA topic, we can highlight the holistic approach to sustainability as a strength of the project. On the other hand, an important weakness is slow regulation and legislation processes within the European Union, and also it requires private fund and investment by the moment until it's replicated and economic sustainable in the market. About the threats, we can talk about new regulation and emission topics and environmental topics, and a changing political and environmental instability in general in the world and European Union. Finally, about the opportunities, we can reach a better use of resources and aluminum throughout the process and the whole life cycles, using new technological resources in the manufacturing process, thanks to FLAMINGo project. The concept of the FLAMINGo project is that nowadays the automotive sector, the two most used materials are steels and aluminum alloys, and the fact that aluminum alloys are an engineering solution to make more to use less material in each piece, and also make these pieces more with a better performance in the vehicle. So with this new approach of manufacturing aluminum-based composite, the objective is to make aluminum an effective substitute to steel, and aluminum recycling is extensively done, and aluminum can be recycled several times. We can reduce all of these impacts, economic and environmental, using these new alloys of aluminum instead of the steel that are using nowadays in the manufacturing of these vehicles. Not only electric vehicles, instead of all of the industry. So the FLAMINGo project will have a duration of 42 months. The principal stages are production of aluminum matrix and alloys master batches to incorporate them to the process. The redesign of the automotive parts and components using this topology optimization to reduce the amount of material used in each piece. Then the optimization of manufacturing methods and demonstration, and the phase 4, the environmental sustainability and circular economy and market issues. This is the phase 4, but we are working on it since phase 1 until the end of the project to have all the information of the possible information to this environmental assessment. You have here like an example of this, like the steering knuckle of the electric vehicle of ALCA. You can see here this vehicle from one of our partners in FLAMINGo, and this is the result using less material designed with this new methodology. So this is like an example, but the idea is to extend this approximation to the whole body of the vehicle. Now we have again this little vehicle. The industrial need is like electric vehicle is supposed to be the next disruptive market force for transportation and technology and this technology. And the electric vehicle manufacturer are convinced that lightweighting is a major topic because it implies less energy to move the vehicle, and it's good for not only the money that costs move the vehicle, instead of the cost of the manufacturing and the reduction of the environmental impact in this manufacturing process. So FLAMINGo aspires to develop a group of integrated technologies that will allow this wide use of aluminum metals matrix on composite in the whole automotive industry, using this advancement in technology and topology optimization and recycling process. So here we have a super quick life cycle analysis approach. We all know that LCA is a technique for determining the environmental aspects and potential impacts associated with the product on the global atmosphere, on the water and the soil nearby system to the study case. We are working obviously in a cradle-to-cradle approximation because the objective is to analyze environmental impact of the whole process. And we're working with some inputs about raw materials, energy, and water. And with these inputs, we try to figure out the performance in these stages of the manufacturing process: the production of raw materials, the production of the components of the vehicle itself, the distribution of the products, and then the use of these products along all its life cycles, and the end of life, and possibly recycling the component of the car, of the vehicle. And the outputs will be the atmospheric emission like in every life cycle analysis, the atmospheric emission, the wastewater and solid waste impacts within the projects. In the typical environmental impact, global warming, ozone depletion, acidification of the soil and water, and all the list of environmental impacts of the life cycle analysis. We are working in the life cycle cost analysis too, not only the life cycle cost, because we have to know we have to get the less cost of manufacture of this kind of vehicle, but being consistent with this quality and function, with no compromising these topics. But it's interesting, and we have to collect data about all the process of manufacture, so we can get data of the money too, and do this life cycle cost analysis. This is a flow diagram of inputs of raw material, energy, and water. And we have the procurement of raw material, casting and extrusion, distribution, use, and aluminum recycling. And the outputs, like we said before. We have now a quick review of the aluminum value chain. This is as we said before, it's this is a critical topic, because it will determine the impact of the next generation of vehicles, electric or not electric vehicle. So in the end of life, we have the disassembling of the whole vehicle for separating the leakage and reuse of hazardous parts, the shredding for separating the fluff and non-metallic compounds, the magnetic separation for the iron, zinc float for plastic, woods, rubber, and heavy materials like high-grade steel, and the current separation for stone. So we have the aluminum, and it can be used for the next generation of vehicles as secondary aluminum, and reducing the environmental impacts of the manufacturing process. To reach these goals, the project considers all the steps from the cradle to cradle, as we said before, like the component design, since the component design, the production of nanoparticles, and then the casting of the components and extrusion of profile with the new aluminum alloys. And then the use of this component for substitution of steel and aluminum parts in electric vehicles, and recycling. And once again, to reduce the economic and environmental impacts of the vehicles manufactured. And the conclusion. So the project is still under development. We have data available of the partners, but it's not the final data. So this lack of data allows us to analyze more scenarios, and we are working on it and drafted, and we are drafting to the data that we don't have yet. But in conclusion, we have to we have to move forward with the sorry. We need to continue collecting this information to complete the LCA and LCCA assessment with the objective of confirming the improvement in performance in economic and environmental aspects of the vehicle manufacturing, using all the enhancements in materials and procedures provided by the project. So in these topics, there are no other companies or consortium that publish this data of life cycle analysis. So this is an opportunity to transparency in these topics. Well, the preliminary analysis of the life cycle set the ground for the main environmental topics to focus on, and we move forward with this recompilation of data in this aspect. So we are working too in the life cycle cost analysis that is still pending, and we have to work on it. So this is the introduction. I don't have any question for now or after.
Thank you, Ramon. Currently, I see no questions in the chat, but we can proceed with the next presentation, and we can take questions for the both of you right after.
Okay,
so let me introduce Mr. Jose Manuel Correa from Global Factor, who is going to give a presentation on the circular economy application after the LCA and Zero Net.
Good
Hello,
morning
Jose.
to all, and let me share my screen, and you can let me know if everything is okay.
Yes, everything looks great.
Okay, perfect. So today I'm gonna talk a little bit more about net zero and the context of net zero, and then we're gonna get into depth of circular economy as a tool to achieve net zero. And this is going to be the transition to the presentation to Tom and Jimena that are going to get into these aspects. So we're going to see the scientific context and political context, then companies and net zero, and the scientific path to net zero based on the Science-Based Target Initiative scheme, and then a little bit of circular economy and net zero to hand over to Jimena and Tom. So let's start by talking about the context of the net zero and climate change a little bit. So first, we will review the concept of net zero emissions and climate neutrality. What we are looking for when we talk about net zero is a balance between the... Sorry, I can... Someone has a question? Or maybe... Maybe we can yeah, okay, that's it. Okay, thank you. I thought someone had a question. So when we talk about net zero, we are looking for a balance between what is emitted into the atmosphere and what we are able to absorb. This is the great challenge that we have as a species. In this sense, the IPCC, that is the Intergovernmental Panel of Experts in Climate Change, assures in its last report that it's the human activity that has led to these changes in climate and in the atmosphere, and that we must mitigate them by aligning ourselves with the international objectives of the Paris Agreement, that is not to exceed the global temperature by 1.5 Celsius. Likewise, because of these studies and these reports, the international community has also set targets for net zero by 2050. You can see it in later. We're going to talk about it in the Green Deal, in the European Green Deal, and in local regulations and laws around Europe. And this is why the UNO has driven media campaigns such as "This is the coolest summer of the rest of your life" and things like that to keep the challenge alive. And that was expressed not only in Glasgow but also in COP27 in Egypt. As I was saying before, the main drivers of this issue at the corporate level are like the regulatory frameworks, such as the European Green Deal and the climate change and energy transition law in Spain, for example, when I was talking about local regulations. These frameworks eventually lead companies to act on climate change mitigation and adaptation issues, as well as to set framed and regulation aligned targets such as net zero by 2050, as had been stipulated in these directives. These obviously always under a scientific base or methodology, and that's why we like to talk about net zero within the science-based target initiative standard. Examples of these regulations can be, for example, in the European Green Deal there has an update lately, that is the Fit for 55 scheme, and also has future changes in the carbon markets, for example, and reduction targets a little bit more aggressive for companies with these new regulations. Also, the climate change and electric or energy efficiency law in Spain says that we have to reduce 23% emissions reductions by 2030, for example, and be net zero emissions by 2050. And also for apart from the important regulations, other important directives that are going around lately to consider are those related to the non-financial reporting information for companies. The European Union has set a framework that is going to be applied after 2024. I mean 2025, and this is going to set a pressure into companies to start doing something about it. The UK is already one step ahead with a regulation requiring listed companies to disclose their decarbonization plans and transitions to net zero starting in 2023 this year, and there is an obligation to publish their greenhouse gas emission targets on scope 1, 2, and 3, the steps to achieve them, and the main milestones towards neutrality by 2050, in line with the international objectives. Also, external verification by a third party is needed in the UK framework. In terms of the EU, as I was saying, the CSR directive also requires in-scope companies to publish information on climate action aligned with the net zero scheme. There is also an obligation to disclose net zero alignment emission reduction targets, reduction measure plans, and budgets allocated to each measure, and offset and neutralization actions and stipulated in the framework of EVRAG. One of I think this slide, you can see the global risk horizon that we wanted to show you here is always climate change. For probably the past 2 years, the main risk in terms of environmental risks, and it also comes as third. In between 0 and 2 years, it comes as third in importance. Between 2 to 5, it comes at first, and between 5 to 10, it always comes at first too. So climate change action failure, it would be the biggest risk. That's why it's putting a lot of pressure into companies too, because to regulations to work and the public sector to be able to achieve these objectives, they have to put the pressure on the private companies so they would act on climate change adaptation and mitigation, and that would help achieve faster the objectives that are met in the regulations. As you can see, a lot of companies like like BlackRock, that is a huge financial group, decided to start drifting investors and their portfolio into a more climate-friendly framework for them, and 75% of the companies got assets net zero aligned by 2030, and that's what they want to do. We also see how stakeholders' pressure, especially investors, become an important drive to reach net zero by decarbonizing their value chain, and as well as reporting to international initiatives such as the CDP, the Carbon Disclosure Project, or align with the Science Based Target Initiative, as we previously said. At the end of the day, companies will have to get in line with these internationally recognized initiatives to meet stakeholder demands and keep being competitive. I want to talk to you now about a little bit more net zeros based on the science-based target standard. As I said before, well, it means that we have to have a balance between the emissions that we drop into the atmosphere or emit in the atmosphere and the ones that we absorb. Companies are required to set reduction targets that are based on scientific evidence and calculation methodologies. And the idea is that we can set targets for a short-term reduction targets for a short term, they would be between 5 and 10 years, and then long term they would be until 2050 or net zero by 2050. I wanna explain a little bit how this works. First, we would talk about abatement within the value chain. It refers to emission reduction measures within the value chain through technology in line with the 1.5 Celsius trajectory. That means energy efficiency and an application of technology that helps you to emit less within your value chain. Then we have the abatement beyond a company's value chain. These are the actions taken by companies to finance emission reductions outside their value chain. These include emission offsets and should be a transitional action, and additional to reductions within the value chain. So in the moment we are here, let's say we're here, and this is our footprint. What we need to do is start reducing all this footprint by year until 2050, and at the same time we can start the abatement outside the value chain. That would be this gray area. That would be the offsetting in the voluntary markets. And then we can start at some point before 2050, start investing in our own absorption projects. So we can start creating absorptions. This the purple color, and we can start creating absorptions. But so when we get to the net zero in 2050, we can have all our remaining emissions that we were not able to reduce being absorbed by our own absorption projects. So these would be the removals, and the removals are, as I said, emission removals through carbon sinks, and nature-based solutions represent the tool that will enable the net zero to be achieved by or before 2050. So in that sense, I want to give the above given the above context, it is important that we see the circular economy as a tool to achieve net zero. Usually we don't see circular economy as a tool to achieve net zero, but we want to get into deep about how circular economy can be a tool. According to a study of the Ellen MacArthur Foundation, the initiatives we have developed so far to mitigate climate change and reduce greenhouse gas emissions cover only 55% of the global emissions. Examples include energy efficiency initiatives and the transition to renewable energies. And the other 45% is related to production and manufacturing, and it is there where we can use circular economy and is proposed to help to reach net zero. I will hand over to my colleagues Jimena and Tom now, who will expand the knowledge on circular economy to reach net zero. And if you have any questions, we're here to respond. Thank you very much.
Thank you very much. So we can move to the next presentation then, and Tom will present along with Mrs. Jimena Franco from TNO and Global Factor, respectively. So the floor is yours.
Thank you, Joanna, and thank you. Thanks to all the colleagues. Well, today we are going to go a little deep into the material analysis and the circularity challenges that the automotive sector presents, and the strategies for integrating this circularity in the automotive industry. This is a joint presentation with my colleague Tom Lichthart, who just presented before, from the ALMA project and Global Factor. We are talking about a contextual framework, and then the circularity in the automotive industry, with some facts and figures and some takeaway messages. In the contextual framework, I will be very quick. This is the last slide my colleague Jose just presented, talking about the big opportunities the circular economy presents for net zero strategies and the decarbonization of the sectors, such as the automotive sector. And then, based on this picture, we can also talk a little bit, or we can add a little bit about the main trends of the automotive sector. In 2022, a study was published based on a very big consultation with automotive stakeholders worldwide. And these are the main trends identified for the sector by 2030. And this is that more than 50% of vehicles in the market by 2030 will have some form of electrification. This is electrification, autonomy, connectivity, and mobility services. Mobility services are also a trend for 2030, and those are some kind of measures based on the circular economy concept. Also, that there's this means that there's a significant increase in the semiconductor content of manufactured vehicles. So this is very important to take into account regarding the materials issue. So this the use of these materials for the semiconductor markets will be 4 times the current markets over the next 20 years. So this is a huge change in the materials demand. The current challenges for the sector is, of course, the high dependence on the supply chain, and this is shown, or this is we can use the example of the microchips shortage that currently we are still suffering. The material shortages and geopolitical uncertainty, global health risks are also and still a big challenge for any sector, and an increasing stringent environmental regulation with decarbonization targets. Finally, the scarcity in the labor market. So this can be synthesized in a high vulnerability of the global automotive supply chain. So what could be the strategies for integrating circularity in the industry? This is a general overview of the strategies, but we will go deeper into these with Tom's intervention. So there are 4 big strategies. We need to develop new models of collaboration between value chain players in order to avoid or just to treat the enormous risk these represent. Second, the regionalizing and optimizing the supply chain. Third, ensuring a supply chain diversity also. And fourth, complying with regulations and ensuring transparency. And in this fourth part is where life cycle assessment and circularity have a most important role. Finally, from my side, I can give the floor to my colleague Tom, who is going to start talking about the material consumption in the sector. Tom.
Okay, thanks, Gina. And if you could, well, first we have this slide just to give an idea how many millions of tons are in the raw materials in the European automotive market. So that's really huge, and it's also telling you that, well, if you can do something in the automotive sector on circularity, you can already have an impact. Next slide, please. Also looking at the discarded vehicles in the EU, so it's in 2020 it was almost 2 million cars being discarded, and that gives also a chance to get back the materials. Further on to the circularity in the MCI and in the circularity, what you do see here, and oh no, I cannot get the point. But what is important? This is a study by Compartimento and others, and it shows which kind of circularity metrics there are already there. Metrics that focus on the resource efficiency, other metrics that more focus on the stocks of materials and the flows within the system. So again, here you have the life cycle going on the left side with the raw material extraction, and then ending at the right side at the use, and then have a loop back via remanufacturing, recycling, but also losses due to landfill and incineration, perhaps with energy recovery. So, for instance, you also have indicators that focus more on at a product level, like the MCI by Alan MacArthur. And just highlighting some things. So at your right hand side, you see that, well, at the end of life, there is a potential for recycling, or even a potential for remanufacturing, and you have to include that in your material choice, but also in your design. So can, for instance, the body in white be reused to make a new vehicle out of it? Another approach is, of course, that's more at the beginning of the chain. So the circle at 14, it pops up at several places, but it's the input of secondary materials. And of course, there also the industry is looking for possibilities of that in steel and aluminium, but also in the plastics and all kind of other materials that are being used in a vehicle. So if you are able to increase that secondary content of a vehicle, you're also on the way of becoming circular. Then things that are more on another level, that 15 and 17, for instance, that these are things about the reuse of parts. Are the parts easy to be reused? Can you do remanufacturing or refurbishment? And of course, ease of recycling. And also in BEV, we saw that there will be debondable joints, for instance, the battery lid on the battery package, so that you can easily remove it at the end of life states. And another thing is that's on a system level, can you make a stable system so that once a vehicle is in the end of life, is there a system there that can make optimal use of that end of life vehicle? So that on circularity, many indicators. Next slide, please. ALMA and FLAMINGo Foundation, they developed a material circularity indicator, and it starts with the virgin feedstock, but also you have accounting for the recycled feedstock. Lifetime is also an aspect to be included. So if you can give your product a longer service life, then that also affects material consumption, circularity in the economy. And can you really get components and materials back to be included again in a new vehicle? And so the MCI, it considers the virgin feedstock, recycling efficiency, also the leaks in the system, unrecoverable waste, and also the use of the product, intensity of use. Yeah, please. So in BEVSIM, this is a way to express the material circularity indicator. At the right-hand side, you see the total, and you do see that at this moment, the default battery electric vehicle and the ICE vehicle do not differ that much in circularity. And of course, it has to do that there are lots of metals, and for metals, we have a well-established recycling system, also, of course, driven by the value and because of the properties of the metals. So with that respect, circularity is already at a level of 0.6. Next slide, please. Then we can also look at the MCI and LCA results. Of course, to keep materials in the loops, you need also input of energy, for instance, for steel in the electric arc furnace to remelt it and refine the waste steel. The same, of course, for aluminium, but also especially with plastics, you have mechanical recycling, but you're going to chemical recycling in the end. And what you do see in this picture is that the BEV is at the left-hand side, so with a circularity of about 0.63, and expressed are also the normalized environmental impacts. The difference in circularity is too small to be significant, but you do see that if you include the use phase, at this moment, the battery electric vehicle has a better performance on climate change, but for instance, for particulate matter, the performance is a bit less. What we can also do is, if we exclude the use phase, that's in the next slide, So then you see that, and especially because of the battery included, but also in this case, because gray electricity was used, the environmental performance of the battery vehicle, it has the higher score. So in this case, it's the lesser environmental performance, the highest impact, the somewhat lesser performance on the environment. But of course, because the use phase is important, you have to go to green electricity, and these kind of effects have also been shown in other studies. And next slide, please. So we had that material circularity indicator. We are also looking at to have the circular footprint formula that was developed for use in the environmental footprint, product environmental footprinting by the EU. It includes the material aspects, virgin material, secondary material, but also recycling and the quality of the material that is being recycled. So that's also of importance. Can you keep your quality of your material even if it's being recycled? But also things like the energy consumption in the life cycle and credits for the energy recovery at the end of life. And then, of course, you may have some remaining waste that becomes final waste, becomes a landfill. In this circularity footprint, it's quite some formula. The factor A, for instance, is of importance. It can have values depending on the type of market between 0.2 and 0.5 by default, and if you have 0.5, burdens and benefits are equally shared between the life cycle delivering the waste product and the life cycle using the recycled materials. So that's also a type of allocation. Next slide, please. The takeaway messages, and as Gimna already mentioned, semiconductors, electronics will become more and more important in future cars, and also, of course, the battery system. In these electronics and in the battery, there are critical raw materials, and critical raw materials, I think that's especially a point to focus on in circularity, because it will be a bottleneck for further development, especially the demands for green electricity. Critical raw materials are a hurdle that will slow down the development of wind power. And as said, we've shown that there are, nearly 60 or perhaps even more circular economy indicators. They are still under development, and you must also include energy in that, I think. What are the efforts you need to keep a material in the loop? Because in some cases, the environmental performance becomes worse when you have to do too much to keep a material in the loop. And so circular and environmental performance may not always go the same way. The circular footprint formula, it does include the energy input, and so that's really a benefit for it. And as already mentioned in this presentation, giving a car a longer service life, design for recycling and design for remanufacturing and refurbishment, they are also important to increase the circularity. And last message, So all these circularity measures, they should also consider the regeneration and restoration, making ecosystem services visible for the value chain. So take the environmental performance also into account, not only look at circularity, but use them all. So this was the presentation by Jimena and by me.
Thank you very much to both of you. I see in the chat that 2 questions have arrived. So the first is for the both of you regarding to plastics usage in the car industry. How does the industry faces towards bioplastics, and is plastic and environmental impact hotspot?
It could be an environmental hotspot when the mass of materials is increasing. Also, you see with compounds that they are not always with mechanical recycling. It's very difficult. So you have to go to, for instance, chemical recycling like dissolution, sulfolysis, pyrolysis, but still you do have losses there. And as said, you also need to input energy and materials for this type of chemical recycling. And what we do see in other sectors that use plastics, for instance, in packaging, there is really now a focus on mono materials but also designed for recycling, so that the things you are making out of plastic can, for instance, be different polymers can easily be separated mechanically, and also can be recycled while maintaining the quality of the plastic, because that's of course is also an important factor. You don't want to have downcycling or at least avoid it to as much as possible.
Thanks again. So regarding the MCI, is this an indicator for projects to be able to enter the market, or it will be forbidden in the future? Is the next question from Marlamatenia Kopliotti.
Yeah, so with the material circularity indicator, you can beforehand have an idea how your circularity performance will be. It's not required, but for instance, also the circular footprint formula that I showed, for instance, in product environmental footprints, following this European environmental footprint, there the circular footprint formula is included, and so then it shows up, that kind of circularity then shows up in your LCA results, not as circularity as such, but as the environmental performance of becoming circular.
Great. One more, I think, is also for the both of you. Circularity and best environmental option at the end of life are not always aligned. So what would be your recommendations to get a better alignment of both goals, like greener and more circular?
Yeah, perhaps if you, I can answer, but you can add, of course, Jimena. As said, with all kinds of composite, multi-material parts in the car, it's important that you also have the recyclability in mind, so that you can easily separate components of different materials, so that each material can into their own most beneficial kind of recycling scheme. So that is of importance. And as said, of course, it's a consumer product, but things like remanufacturing, refurbishment. I think refurbishment is well, in some sectors it's already there, like copying machines, but perhaps it could also be part of the automotive industry. Still, the consumer wants to have a new car once in a while.
Tom, I would add there that this is a very good example of how important is the taking into account environmental footprints and environmental impacts since the design phase. So circularity and environmental footprint would be more together if we take into account the different environmental impacts since the design of the products, taking into account all the steps of in the life cycle of any kind of product.
Thank you both for your replies. And thank you everyone for the interesting presentations. I am very happy for the engagement of the audience and for replying to actual questions and for sharing your knowledge on the topics. If we do not have any further questions, I don't know if there are any more to come for the next 4 minutes that we have. Or we can conclude this first session a little bit earlier, if this is okay with you. According to the agenda, we have a short break now, and we can all meet back at 12:05.